Hello, welcome to the Extraordinaire. Today we're going to be going over list comprehensions, and the list comprehensions provide a concise way to create lists. Common applications are to make new lists where each element is the result of some operations applied to each member of another sequence or iterable, or create a subsequence of those elements that satisfy a certain condition. So if we want to create a list out of processing another list, it's very easy to do that using a list comprehension. So if we have a list of numbers from 0 to 9 and we want to create the squares of those numbers, a list comprehension comes in handy in this case. Let's write the code. We'll create a file here, say example1. In this file, we can write squares is equal to this for x in range 10 square dot append x, and if we come and print it here, we have a list of squares. So let's run this and see how it looks. Hold on. Okay, we didn't add the rest to part 2, so let's do it again. So we have a list of squares here. Now this is how we would normally do this, but this is not a list comprehension. We could also do something like this, where we use a lambda operation and a map. So we could say, for example, squares list map, and then we use a lambda expression as the function for this map. And here we can print the squares. This also achieves the goal, but again, this is not a list comprehension. What we are looking at trying to do is something like this instead. So this is a list comprehension. As you can see, this is more concise and readable. A list comprehension consists of a bracket. So we have the opening and closing bracket, square brackets, and then it contains an expression. This is the expression, followed by a for clause, then 0 or more for or if clauses. The result of a list comprehension is a new list resulting from evaluating the expression in the context of the for and if clauses which follow it. For example, if we want to do, let's comment this out, want to do something like this, I will say x comma y for x in 1, 2, 3, for y in 3, 1, 4. If x is not equal to y. What this is doing is it's creating a tuple of x and y for this list 1, 2, 3 and this list 3, 1, 4, where x and y are not equal to each other. what do we have? Let me assign this to a variable. And we see that each of these tuples in the list is a combination of numbers from both lists that are not equal to each other. So we have 1 3, 1 4, 2 3, 2 1, and so on and so forth. So this is how we create list comprehensions using multiple for clauses as well as an if clause. This code that we just wrote here in a single line is equivalent to this. Notice that the order of the for and if statements are the same as in the list comprehension here. If the expression is a tuple, for example x comma y, as in the previous example, it must be parenthesized. We can use this list comprehension for a lot of things. Let's quickly go over some of the ways that we can use them. I'll create a new file. We'll save this as example2. So we'll define a vector list. Then we can create a new list with the values of this vector list doubled. So let's see how that goes. So we say doubled equal x times 2 for x in vec. And we'll print this. And we run it. We have we see -4 becomes -8, -2 becomes -4, 0 is 0, 4, 2 becomes 4, and 4 becomes 8. So this initial list is doubled. We could also filter the list to exclude negative numbers. So say remove negatives. Save x for x in vec if x is greater than or equal to 0. And we'll print this. We have only the positive values 0, 2, and 4. We could also apply a function to all the elements in the list. And how that would work is, we say apply function. Can get the absolute value of x for x in the vector list. Save this, print apply function, and run. Now we get the absolute value, and what we have is 42024. We could call a method on each element on the list. For this, we'll define a new list. Let's comment this out. We'll define a new list. We'll say fresh fruits. And here we have banana with some space in front of it. Then we have Loganberry with some space in front of it as well, and we have passion fruit with some space after it. Now we can strip out all those spaces on each of the items in the list. So let's create another list called fresh fruits stripped. That will be equal to, I'll say, fruit for fruit in fresh fruits. And now we can print the original, so we'll call this fresh fruit. And then we'll print the stripped version, fresh fruit stripped. So we see the difference between the two. Let's run this. So we see fresh fruit is the original list we had with all the spaces in there, and fresh fruit stripped, oh sorry, I didn't run the function on it, so I'm just going to add that now. So strip, let's run this again. Good. So we have our original list with the spaces in there, and we have the fresh fruit stripped without any of those spaces in the beginning or at the end of the string. Another thing that we could do is we could create a list of two tuples, like the number and the square of that number. So for example, we can have a list of, let's say, tuples, and here we have to put our parenthesis x raised to the power 2 for x in range of 6, and we print these tuples. What do we have? So we have 0 0 1 1 2 4 3 9 4 16 and 5 25. Remember, 6 is not included in the range because that is the end of the range. So it starts from 0 to 5. That's why this list ends at 5 and 25, which is the number 5 and its square 25. Before we go ahead, we also have to take note that for tuples there has to be a parenthesis. If we do not include a parenthesis, we get an error. Let's take a look at what happens. Let's duplicate this, comment the first example out, and just remove this parenthesis. Let's run this again and see what we get. We see that it's complaining about this section of the code, which is here. And why is that? Because it requires for us to add, Python requires us to add parentheses whenever we are creating tuples like this. We can comment that out for now. We can flatten a list using a list comprehension with 2 4s. So imagine we have a vector like this, where there is a list in it, and that list contains other lists. So we have 1 2 3 and another list 2 4 5 6, and yet another list 7 8, 9. We can flatten this list by writing a list comprehension. So we'll say flatten vec, and in here we have norm of L in vec for norm in ln. Let me explain what's going on here. Hold on, there's an error here somewhere. Okay, norm for, it's not off, norm for element in vec for norm in element. Let me explain what is happening here. Remember, we said that the expression is based on the for that comes immediately after it. So in this case, we have norm for element in vec for norm in element. Now we are defining element here in vec, which gives us the lists that are in the vec. So lm here is going to hold each of these lists. Then we are saying for each number that is in each of these lists that is in lm, we want to print that number into a new list, and that means it's just going to pick this number 1, this number 2, this number 3, this number 4, 5, 6, 7, 8, one after the other, and need to print that out. Don't worry if you do not understand this yet. As we continue to learn about Python, things like this will become more clear. So let's print this and see what it looks like. So we see that this vector has been flattened. Our list expressions can contain complex expressions and nested functions. Let's see an example of that. Create a new file, save this as example 3.py. So in order for us to do this example, we are going to import the pi constant from the math module. So say from math import pi, and here we're going to say values of pi is equal to string round pi for I in range 1,6. What's happening here is we're creating a list of strings with the values of pi rounded to a particular significant value. So that significant value is based on the range that we have here, which is going to start from 1 and stop at 5. Let's print the value. Python 3, example 3. You will see that the first value has the value of pi with one significant figure. The second has it with 2 significant figures. The third has it with 3 significant figures, 4 significant figures, 5 significant figures, and that's what this does. We can also have nested list comprehensions. Say we have a matrix, for example, we can transpose the rows and columns of a matrix. You can check out what that means. You can Google what it means to transpose a matrix, but the long and short of it is basically to turn the matrix on its diagonal. As I've said before, don't worry if you do not understand some of these concepts. Let's just keep going, and as we continue, many of them will become clearer and clearer as we handle more examples. So let's do this example. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12. Save this as example 4. Great. Now we can transpose this matrix. So transpose rows, row I for row in matrix, for I in range 4. And if we print this, hold on, that's example 3, example 4. Now we get the transpose of this matrix. We could achieve the same result by writing it this way or writing the code this way. But again, this is more terse, it's more readable, and the syntax uses less characters, less lines of code. In the real world, you should prefer built-in functions to complex flow statements. The zip function would go do a great job for this use case. So instead of doing all of this, we could just go to list of zip asterisk matrix, and this should give us the same result. Yes. One more thing that we need to go over before we close out for today is the delete statement. The delete statement is a way to remove an item from a list given its index instead of its value. It differs from the pop method, which returns a value. The delete statement can also be used to remove slices from a list or clear the entire list, which we did earlier by assignment of an empty list to the slice. So let's see an example of this. Example 5.py. Close this out, and let's have a list. Say A is equal to -1, -1, 66.25, 333, 333, 123, 4.5. And here we can delete A0. The 0 gives us the index, is the index of the list that we want to delete. So in this case, this will delete the first item on the list. And if we should print A at this point, we'll see that -1 is no longer in the list. Right. So we have 166.25, 333, 333, 1 to 3.5. No more -1. Notice that we've removed -1. Now we want to delete from 2, which means that at this point, this one value would be our 0 index, 66.25 would be our 1 index, and then 333 would be our 2 index. We want to delete from 2 to 4, and when we are slicing, the slice stops 1 before the number that is the second number, so which means that this would stop at 3, which is this 333. So let's look at that example. A to column 4, and if we print A here, what do we get? So the first one gives us our initial list without -1. The second one gives us the list without 333 and 333. Finally, if we want to delete the entire list, we can say delete A column like this and delete the entire list. As you can see here, so the list has been cleared. That's it for list comprehensions and the delete statement. If you enjoyed the content, please like, subscribe, share with others, and I'll see you in the next one. Bye.